Have you ever looked up at an airplane soaring through the sky and wondered, how does it stay up there? It's a question that has captivated people for centuries. And the answer lies in a fascinating combination of physics and engineering. Airplanes, those magnificent feats of human ingenuity, rely on powerful engines to generate an incredible force called thrust. This thrust, like an invisible hand, propels the airplane forward, allowing its wings to generate lift and overcome the force of gravity. But how do these engines work? It's not magic, though it might seem like it. In simple terms, airplane engines work by taking in air and using it to burn fuel, which creates hot, expanding gas. This gas is then expelled out the back of the engine, creating a powerful force in the opposite direction, thrust. This principle, based on Isaac Newton's third law of motion, for every action, there is an equal and opposite reaction, is what allows airplanes to move forward and ultimately take flight. Understanding how airplane engines work is like unlocking a secret world of power and precision. Throughout this essay, we'll delve into the heart of these incredible machines, exploring the key components that make flight possible. From the mighty compressors that squeeze air to the fiery combustion chambers where fuel ignites, we'll uncover the secrets of how airplanes power through the skies. So, buckle up and get ready for a thrilling journey into the world of airplane engines. To truly grasp the marvel of airplane engines, we must first understand the concept of thrust. In the simplest terms, thrust is the force that propels an airplane forward. Imagine yourself standing on a skateboard with a basketball in hand. If you throw the basketball forward, the force of your throw will cause you to roll backward on the skateboard. This is a basic demonstration of thrust. In an airplane engine, thrust is generated by expelling a jet of hot gas out of the back of the engine. This jet of gas creates an equal and opposite force that pushes the airplane forward, just like throwing the basketball pushed you backward on the skateboard. The faster and heavier the jet of gas, the greater the thrust produced. But how does an airplane engine create this powerful jet of gas? That's where the engine's internal components come into play. By working together in perfect harmony, these components create a continuous cycle of air intake, compression, combustion, and exhaust, ultimately producing the thrust needed for flight. In the following sections, we'll take a closer look at each of these key components and see how they contribute to the generation of thrust. The first stage in an airplane engine's thrust-generating process takes place in the compressor. Think of the compressor as a giant fan, or better yet, a series of rotating blades that act like air pumps. Its job is to draw in vast quantities of air and squeeze it into a smaller space. Why is compressing the air so important? Compressing air increases its density and pressure, which is crucial for efficient combustion. Imagine trying to light a campfire with loose kindling versus tightly packed logs. The tightly packed logs will burn hotter and more efficiently because the fire has less space to spread out. Similarly, compressing the air in an engine allows the fuel to burn more efficiently, releasing more energy and ultimately producing more thrust. The compressor is a marvel of engineering, with multiple stages of rotating blades that progressively increase the air pressure as it travels through the engine. In the next section, we'll explore what happens to this compressed air as it enters the combustion chamber. Once the air has been compressed, it enters the combustion chamber, the heart of the engine where the real magic happens. This is where the compressed air mixes with fuel and ignites, creating a continuous explosion that generates the hot, expanding gas essential for thrust. Imagine a car engine's cylinders, where the spark plugs ignite the fuel-air mixture. Similarly, the combustion chamber in an airplane engine is where the fuel and air, now under high pressure, meet and ignite. However, instead of spark plugs, airplane engines use a continuous ignition system, where a flame is constantly present to ignite the incoming fuel-air mixture. This continuous combustion process creates extremely high temperatures, reaching thousands of degrees Fahrenheit. The intense heat causes the gases to expand rapidly, forcing them out of the combustion chamber and into the next stage of the engine, the turbine. Section 5. Turbines. Harnessing the power of hot air. After the fiery combustion process, the hot, expanding gases rush through the turbine section of the engine. The turbine consists of another set of specially designed blades, much like the compressor but with a crucial difference. These blades are connected to a shaft that runs the length of the engine. As the hot gases blast through the turbine blades, they cause the turbine to spin rapidly, just like wind spins a windmill. This spinning motion is what powers the compressor at the front of the engine, drawing in more air and sustaining the continuous cycle of compression, combustion, and exhaust. However, the turbine's job isn't finished yet. The spinning turbine shaft also powers a large fan at the front of the engine in many modern jet engines. This fan, known as a bypass fan, is responsible for a significant portion of the engine's thrust, especially at lower speeds during takeoff and climb. Now, let's explore the different types of airplane engines that utilize these fundamental components to power the skies. Section 6. Jet engines powering through the skies at high speed. When most people think of airplane engines, they picture the sleek and powerful jet engine. Jet engines, also known as turbojet engines, are renowned for their ability to propel aircraft at incredible speeds, making them ideal for long-distance travel. Jet engines work on the same fundamental principles of air intake, compression, combustion, and exhaust that we've discussed. However, they excel at generating thrust by expelling a high-speed jet of hot gas out of the back of the engine. This jet of gas creates a powerful forward force, propelling the aircraft to impressive speeds. One of the key features of jet engines is their ability to operate efficiently at high altitudes where the air is thinner. This is crucial for long-haul flights, as flying at higher altitudes reduces air resistance and improves fuel efficiency. Section 7. Turboprop engines, a combination of jet power and propeller thrust. While jet engines are ideal for high-speed flight, turboprop engines offer a different approach to powering aircraft. Turboprop engines combine the power of a gas turbine engine with the thrust-generating capabilities of a propeller. Like jet engines, turboprop engines utilize a compressor, combustion chamber, and turbine to generate power. However, instead of expelling the majority of the hot gas as thrust, turboprop engines use the turbine to spin a propeller at the front of the engine. This spinning propeller acts like a giant fan, pulling air through the engine and creating thrust by displacing air backward. Turboprop engines are particularly well suited for shorter flights and takeoffs from shorter runways. Their propellers provide excellent low-speed thrust, making them efficient for regional air travel. Section 8. Beyond the basics. Other types of aircraft engines. While jet and turboprop engines are the most common types found on commercial aircraft, several other types of aircraft engines have been developed for specific purposes. These include turbofan engines. A variation of the turbojet engine, turbofan engines feature a larger fan at the front that bypasses some of the air around the engine core. This design improves fuel efficiency and reduces noise, making them a popular choice for modern airliners. Ramjet engines. Unlike other jet engines, ramjet engines have no moving parts in their basic form. They rely on the forward motion of the aircraft to compress incoming air, making them suitable for high-speed supersonic flight. Rocket engines. Unlike air-breathing engines, rocket engines carry their own oxygen supply, allowing them to operate in the vacuum of space. They generate thrust by expelling hot gas from the combustion of fuel and an oxidizer. Each of these engine types plays a crucial role in specific areas of aviation, demonstrating the diverse and innovative nature of aircraft propulsion systems. Section 9. The importance of understanding engines for aviation enthusiasts. From the earliest days of flight, airplane engines have been a source of fascination and wonder. Understanding how these intricate machines work enhances our appreciation for the science, engineering, and sheer ingenuity that makes flight possible. For aviation enthusiasts, delving into the world of airplane engines unlocks a deeper understanding of the capabilities and limitations of different aircraft. Whether you're captivated by the roar of a jet engine or the rhythmic hum of a turboprop, knowing how these engines function adds a new dimension to the thrill of watching an airplane soar through the sky. Moreover, understanding the basic principles of aircraft propulsion fosters a greater appreciation for the constant innovation and technological advancements driving the aviation industry forward. As we look to the future of flight, one thing is certain: airplane engines will continue to play a pivotal role in shaping the way we explore the skies and beyond.